Hello and a big welcome to CBSE with Sudhir, where we are going to study an extremely fascinating chapter called Magnets. It's called Exploring Magnets, the World of Magnetism. And I am pretty sure you will find this particular explanation video very interesting because बहुत कुछ दिखाने को भी है. Because magnet, I remember as a child, one used to find it very fascinating how magnets are able to attract anyone, right? So that is something very interesting. So I will, what I've also done is to think from the point of view of a 11-year-old, right? Most sixth class students would be 11-year-old students. So what are the kind of questions that you are likely to have, and try to explain that in a separate note as well. So this is the story, which the chapter begins with the story. Reshma lives in a coastal town of Kerala, यानी कि Kerala, which is a coastal state, यानी कि तटीय क्षेत्र है. वहां पर if you see the coastal areas like Kochi or Thiruvananthapuram, Kovalam, these are all facing the coast. Kannur, etc. They're Kozhikode, they're all facing the coast. तो उसके एक शहर में रेशमा रहती है and she is very fond of writing short stories. Okay, कहानियां लिखने का उसको बहुत शौक है. Her grandmother loves listening to her stories, so Reshma was writing a new story to share with her grandmother on her 60th birthday. Fine, this almost seems like an English chapter, right? That she likes writing stories, so she wants to write a story and present it to her grandmother on her 60th birthday. यानी कि जब वो 60 साल की हो जाएंगी, 60 साल की हो जाएंगी, तब as a present she wants to gift her a short story. Now, what is the story about? The story was based on a ship carrying spices from Kerala for trade in the olden days. Now, if you know, I don't know if you know, Kerala is known for its spices. Spices ka matlab, cardamom hua, different kinds of, things which are used in the business of cooking. Uske bare mein hua, cashew hua. So these are all spices which are grown a lot in Kerala, right? So she was writing a story for that. And if you remember, Vasco da Gama first landed in Kerala, near Calicut. Calicut bolte the, aajkal Kozhikode bolte hain, in the northern part of Kerala. So he came actually, basically the people who came earlier were all spice traders. They wanted to trade in spices. So Reshma was aware in those days the sailors used stars to find directions at night. So she's thinking that if someone goes in a ship like this at night, okay, you can say during the day you can find out from the direction of the sun that this is east and this is west, है ना? But मैं सोचता हूं अब क्या कीजिएगा जबकि टाइम हो दोपहर के 12 बजे, that is the sun is right above. How would you know whether it will go this side or this side, whether this is east or this is west? You don't know that, right? And रात के समय पर how will you know the direction? So she always used to wonder how do they know the directions and whether they know the directions from the direction of the stars. And stars mein there are some bright stars, Dhruv Tara bolte hain. There is the Orion. Okay, why I know Orion is because in class 12, when I was in class 12, my project was on astronomy. So every night I used to spend an hour looking at the sky and making the pattern of stars over a period of 15 days. Okay, that was my project in class 12. So Orion is a thing of, there are 3 stars in one line, that is called Orion. So sailors use stars to find directions at night. But in her story, a situation arose where the sailors got caught in a storm with an overcast sky and stars were not visible. So stars were not visible. It may not be a full moon night, so you may not even know the direction of the moon, right? So how do you know that if I have to go, suppose you are somewhere in the Arabian Sea. Arabian Sea is India ke left mein. So you want to reach Mumbai port. But how would you know that how do I go in an east, northeast kind of direction? Hai na? So for that, what is the way? The stars are not visible, the moon is not visible. So Reshma could not take her story forward as she could not think of a way for sailors to find directions. So she could not find that. Now let me explain that further. Meanwhile, have you pressed the subscribe button? Okay, I find it very surprising that if there are 100 students, out of the 100% students who use our content, only 18%, in fact less than 18%, 17.8 have subscribed. 82% plus students have not subscribed. Please remember, this is free of cost. It gives me an idea as to how many students are from class 6, from different classes, so that you accordingly make content. That's the only idea. It helps you and it also encourages. So this is like a ship. I have put a bigger photograph where it is caught in the storm. It is a very rough sea and it will not know in which direction to go. For all you know, it may be going in the completely wrong direction. Okay, because there is no way. So how do they know which direction to go in? So what they do is to use this particular device called the magnetic compass. Magnetic compass, if you see, it shows the direction north and south. तो अगर north ये है और south ये है, so obviously it means east is this way. So if you have to go in a northeast direction, you will go between north and east and proceed like this, right? And you will reach Mumbai if you are caught in the Arabian Sea. So this is called a magnetic compass. Okay, let's come back to the chapter. So she searched for information on the internet and her school library. She learned that the travelers used a device known as a magnetic compass for finding directions. North, south, east, west. So this is northeast, right? So Reshma had seen pencil boxes and purses which had magnets. Now, आपके मम्मी के handbag में कभी-कभी there is a magnet so that it kind of presses and the flap of the purse closes so that nobody is able to open it and pickpocket. So वो magnetic उसमें भी use होता है. Cupboards में you go and open the cupboard at your home. So the moment the door goes near the final position, there will be a magnet which the carpenter would have fixed inside and it will immediately suck and it will get closed like this so that no insects or anything can go inside the almirah, the cupboard. A writing board in her school also had a duster with the magnet. So she's able to remember, magnetic compass. I know of all these things जो कि magnet का इस्तेमाल करते हैं. तो she's able to correlate. Magnet का इस्तेमाल तो इस तरह से किया जाता है. But she had never looked at those carefully. She now became curious to learn more about magnets and magnetic compass. कि अभी story को तो छोड़ो, उससे पहले I want to know more about magnets and magnetic compass. Now, you know something, this has a magnet. This has a magnet. So if there is an iron table on the side, it's not in the frame. If I put it directly there, वो चिपक जाता है. Okay, therefore I have to always keep it inside a box, a cardboard box, so that it doesn't get stuck to the iron table. Now, इसको अलग रखता हूं. Okay, now all these things have, like, this is the magnet that I was talking about. यहाँ पे मैग्नेट है, यहाँ पे मैग्नेट है. सो जैसे ही दरवाजा बंद होगा करके बंद हो जाएगा. यू वुड हैव सीन रेफ्रिजरेटर्स के ऊपर, लाइक फॉर इंस्टेंस दिस इज मैग्नेट which is there on the refrigerator of at my home. Okay, it's not coming directly in focus. Focus करो बेटा. फोकस ठीक से नहीं हो रहा गणपति का फोटोग्राफ. So you see पीछे इसके मैग्नेट है. There is a magnet behind जो कि फ्रिज पर चिपक जाता है, that you can see in this photograph out here. Similarly, lunch box, cell phone flap, duster, this kind of things to put pins, etc. also have magnets. Now let me tell you what exactly are magnets. Okay, ताकि आपको समझ में ज्यादा आसानी से आए, and then we'll come back to the text. See, ये करने से पहले मैं now this is another magnet, a U-shaped magnet. Okay, with the north and south pole. ये एक दूसरा है. And if you see here, the pencil का जो lead है, that is non-magnetic. So that will not get attracted. ये इसके साथ चिपकेगा नहीं. Okay, paper नहीं चिपकेगा, लकड़ी नहीं चिपकेगी. Okay, so all this is there. Now what are magnets? Let's go through this first. Magnets can be formed through several natural and artificial processes. Okay, now magnet होता ये है क्योंकि it is able to attract something. Actually, मैं पहले चैप्टर से पढ़ाता हूं, उसके बाद इसको और डिटेल में पढ़ेंगे. Now the magnets used by sailors in the olden days were based on naturally occurring magnets. I'll come back to that. Okay, naturally occurring magnets known as lodestones. Okay, lodestones का नोट कर लो, मैं बताऊंगा डिटेल में lodestones भले होते क्या हैं. Okay, which were discovered in ancient times. Later on, people found that magnets could also be made, artificially made, from pieces of iron. Nowadays, we have magnets made of different materials. The magnets that you find in your school laboratory and those used in the pencil box stickers, etc., are all artificial magnets. They are not natural magnets. Okay, the magnets can be of various shapes, some of which are shown. This is a bar magnet. ये मेरे स्कूल के टाइम का है. I hope you can see this. Okay, ये जो डॉट है that conveys जो ऊपर जो डॉट दिख रहा है white dot, that conveys that it is the north pole. दूसरी तरफ साउथ पोल है. So this is the magnet that you can see, bar magnet on the left hand side of the screen. Same thing. ये मेरे स्कूल के टाइम से एक और होता था, पता नहीं कहां गया. Okay, this is a U-shaped magnet and this is a ring magnet. Okay, तो यहां तक आते हैं. Now let me explain to you further. Okay, what are magnets? Now magnets can be formed through several natural and artificial processes, जो अभी बताया. पहले natural magnets are lodestones. Lodestones जो कि है क्या? Lodestones are naturally occurring magnets. They are the naturally occurring magnets. They are formed over a long period of time through natural processes. Okay, जो अभी जैसे this one that is there, it's an artificially made magnet. लेकिन जो lodestones हैं, they are naturally formed magnets through natural processes as the Earth's magnetic field acting on certain minerals, particularly magnetite. So, how is Earth a magnet? उसके बारे में I will tell you after this, because I'm very sure these must all be questions that will come. The textbook does not sufficiently answer all these questions. Even though the textbook is called Curiosity, I wish they had explained this in more detail. Now, in the presence of the Earth's magnetic field, इस बात को जरा ध्यान में रखो कि Earth का magnetic field भला होता क्या है, मैं बताऊंगा. Okay, some regions within the magnetite become aligned. जो magnetite करके जो mineral है, वो एक तरह से अलाइन हो जाता है अर्थ की मैग्नेटिक फील्ड से. इट स्टार्ट्स अलाइन का मतलब इट स्टार्ट्स रिएक्टिंग टू द मैग्नेटिक फील्ड ऑफ द अर्थ, causing the material to develop a magnetic field, so that magnetite becomes a magnetic field and becomes a natural magnet. So that is what is called the natural magnet, where magnetite reacts to the magnetic field of the earth and becomes a natural magnet. Simple चीज में ये है. दूसरा है artificial magnets, which are temporary magnets. They can become magnetized temporarily when exposed to a magnetic field, but lose their magnetism when the external field is removed. Now, I'll show you something. Now, again, इसमें focusing का problem है. ये है, आपको दिख रहा है. I hope you can see this. This is a safety pin. Okay, you can see this. Yeah, focus में दिख रहा है. Now, this is a safety pin. I have put a couple of safety pins out here on this book. Okay, अब मैं इसको ये करूंगा तो नीचे गिर जाएगा. ये आपको I don't know whether दिख रहा है. इसके ऊपर मैंने दो सेफ्टी पिन, 1 and 2 सेफ्टी पिन्स यहाँ पे लगाए हैं. Now if you see, this is a magnet that I have in my hand, right? This is a magnet that I have in my hand. Let me see whether the focus is आ रहा है नहीं. Now मैं इसको आता हूं, आप इसको देख सकते हैं. It has got hold of this. अभी इसी को लेकर मैं दूसरा इसको भी मैं पकड़ लेता हूं. So you see, it is acting as the first safety pin is also acting as a magnet in order to catch hold of the other safety pin. Okay, so that's what. So the first safety pin has also become a magnet of sorts. Okay, लेकिन once I remove the magnet, those two will become separated. Okay, so that is what. So permanent magnets are materials that once magnetized retain their magnetic properties for a long time. For example, a material like iron, cobalt, nickel can become a magnet by placing it in a strong magnetic field. It will retain this magnetization even after the external field is removed. This I am telling you this slightly extra information, but अगर आप पूरी तरह जानेंगे, later on when you reach class 8, 9, when there are chapters relating to magnetic property, magnetism के बारे में और डिटेल पढ़ेंगे, this kind of basic information अगर आपका फाउंडेशन स्ट्रांग है, आपको उस समय पर आसानी होगी. That is my basic idea. Now, ओके, ये हो गया. एक और मैं आपको दिखा रहा हूं. ये देखिए, फ्रिज के ऊपर, दिस इज अ रेफ्रिजरेटर. ये रेफ्रिजरेटर का डोर, उसके ऊपर आप इस तरह का मैग्नेट प्लेस कर रहे हैं, इसको चिपका रहे हैं, जस्ट लाइक व्हाट आई शोड यू. दिस गणपति स्टिकर, because of this magnet, it is able to stick onto our refrigerator. Now let me go back to talking about earth ka magnetic field. Okay, now Earth ka, how is Earth a magnet? Now this note is very important. I have kept it as simple and concise as possible. How is the Earth a magnet? The Earth acts as a giant magnet due to the movement of molten, वो लावा बोलते हैं ना, वॉल्केनो की तरह इरप्ट होता है, अंदर मोल्टन लावा वगैरह होता है. सो उसका जो मूवमेंट अर्थ के सरफेस के अंदर होता है, so due to the movement of molten iron and other metals in its outer core, this movement generates a magnetic field which extends from the core out into space, that is from the surface into space, okay, influencing various natural phenomena and protecting the planet from harmful solar radiation. So it kind of protects us from the sun's radiations, also the harmful radiations. And this is the, in a nutshell, this is why Earth is also a magnet. Now, you can very well ask this question, and I think it's a very logical question as to हम सभी अर्थ के ऊपर चिपके हुए हैं, है ना? So that means gravity is also one form of magnetism. Logical question, that whether gravity is also one form of magnetism. No, gravity and magnetism are very different. The law of gravity as framed by Newton. Gravity is not a form of Earth's magnetism. Gravity is the force that makes objects fall to the ground and keeps planets in orbit around the sun. See, agar gravity hota, abhi what did I show you? That only certain metals are attracted towards a magnet. They are only magnet. For example, if I have this magnet and let me say this is a highlighter. इसको मैं चिपकाने की कोशिश करूंगा, चिपक रहा है? नहीं चिपक रहा है. Why? Because this is plastic, which means this is non-magnetic, है ना? Now, this is a stainless steel spoon. ये चिपक रहा है? नहीं चिपक रहा है. Why? Because this is also non-magnetic in nature. However, this one, a screwdriver. You see this? It has got stuck to it, right? Because this is made of iron, which is a magnetic material. You understand the difference? So only magnetic materials, metals, will get stuck to a magnet, will get attracted to a magnet, whereas plastic, stainless steel, etc. will not. For example, this one, you see this? This is the clip for the mic. So this is a magnetic material and it is getting stuck to the magnet. Okay, I hope I'm able to make you understand this. So gravity affects all objects with mass regardless of their material composition or whether they are magnetic. Like, are we magnetic? No, but we are also stuck to the earth. Plastic, plastic is, मैं इस highlighter को नीचे जमीन पर डालूंगा, it will, I mean, in a way get stuck to the earth, you know, it will be on the earth. Is this magnetic? This is not magnetic. Stainless steel spoon, it is not magnetic, but it is falling. The screwdriver, which is magnetic, also falls. So gravity is not magnetism. So please remember, there is a difference between gravity and magnetism. This is a logical question जो कि दिमाग में आता है. So lodestones के बारे में जो मैंने बताया वो होते क्या है? Now lodestones are naturally magnetized pieces of the mineral magnetite. Okay, they have, because book में वो ठीक से नहीं दिया है, they have the unique ability to attract iron and are one of the first materials discovered to possess magnetic properties. So lodestones in that sense are important. इस definition को आप याद रख लीजिए, आपके काम आएगा. Historically, lodestones were used in early compasses because they could align themselves with the Earth's magnetic field, pointing towards the magnetic poles. Historically, they were used in the early, जो magnetic compass जो मैंने शुरू में दिखाया, उसमें लोडस्टोन्स का इस्तेमाल होता था बिकॉज उनमें वो क्षमता थी, उनमें वो एबिलिटी थी कि वो करेक्टली अलाइन कर पाते अपने आप को अर्थ के, पृथ्वी के मैग्नेटिक फील्ड के साथ. They could align themselves with the magnetic field of the earth and they would kind of point towards the magnetic poles. This made them valuable for navigation, especially on the sea, कि किस तरफ जाने से हम नॉर्दर्न डायरेक्शन में जाएंगे, किस तरफ जाने से हम वेस्टर्न डायरेक्शन में जाएंगे. ओके, सो इसका एक और फायदा है कि दे वर आल्सो नोन टू बी हैविंग प्रोटेक्टिव और हीलिंग पावर्स प्रॉपर्टीज माना जाता है. सो मैग्नेट इज मेड अप ऑफ टाइनी रीजन्स. ओके, इसके ऊपर बाद में आएंगे. ओके, तो यहां तक का आई होप आपको समझ में आ गया. थोड़ा इंटरेस्टिंग भी लग रहा है, मैं उम्मीद करता हूं. नाउ लेट्स एक्सप्लोर कलेक्टिव फ्यू ऑब्जेक्ट्स मेड ऑफ. ये सब मैंने अभी आपको दिखा दिया. ये सब आई हैव शोन यू ऑलरेडी प्रैक्टिकल डेमोन्स्ट्रेशन में. आप ये सभी अपने आप कर सकते हैं. यू कैन पिक अप थिंग्स लाइक ए ग्लास टम्बलर, किचन से लेके आइए. पेन तो आपके स्टडी टेबल पे होगा, उसको चेक कीजिए. फॉर एग्जाम्पल ये जो है कहां गया वो, पेन कहां गया. अभी ये जो पेन है इस पे चिपकेगा नहीं चिपकेगा, सो दैट डजंट वर्क. कैंची को कीजिए. कैंची अगर स्टेनलेस स्टील की होगी तो नहीं होगी, अगर लोहे की होगी तो चिपकेगी. कैंडल नहीं चिपकेगा. रूलर अगर लोहे का है तो होगा, प्लास्टिक या ग्लास का होगा तो नहीं होगा. राइट. स्टेपलर कैन स्टिक डिपेंडिंग ऑन द मटेरियल. समटाइम्स उसका जो स्टेपल्स है वो स्टिक हो जाएगा, लेकिन स्टेपलर अगर स्टेनलेस स्टील का है तो नहीं होगा. पेंसिल नहीं होगा, क्लॉथ नहीं होगा. इस तरह का क्लिप आई हैव ऑलरेडी जस्ट नाउ शोन टू यू. दिस विल स्टिक, दिस विल स्टिक. ओके, मैच बॉक्स विल नॉट स्टिक. सो यू नीड टू राइट डाउन कि कौन कौन सा स्टिक होता है, कौन कौन सा नहीं होता है टू द मैग्नेट. ओके, सो दिस आई हैव शोन यू प्रैक्टिकली. सो the materials which are attracted towards a magnet are called magnetic materials. So this particular screwdriver is a magnetic material, right? This is made of silver. Okay, this religious symbol is made of silver. This will not get attracted. This will not get attracted to the magnet. So this is a non-magnetic material. So the metal iron is a magnetic material. Lead, which is used in the pencil, is not. Nickel and cobalt are also magnetic material. Some of their combination with other material like nickel और cobalt को किसी और मेटल के साथ मिक्स कर दो, जो कि आप केमिस्ट्री में पढ़ेंगे. They are also attracted towards magnets because उसमें nickel और cobalt का some element will be there. The materials which are not attracted are called non-magnetic materials. यहां तक I hope आपको पूरी तरह से क्लैरिटी हो गई है. There is no confusion. वो लोड स्टोन्स वगैरह का आई विल पुट दिस इन द बेसिक डेफिनेशन में कमेंट सेक्शन में डाल दूंगा, ताकि आपको कट पेस्ट करके आसानी होगी अपने नोटबुक में लिखने के लिए. इट्स मच इजियर देन पुटिंग इट इन गूगल ड्राइव एक्सेट्रा. ओके, जो भी इंपॉर्टेंट पॉइंट है मैं उसमें लिख दूंगा. नाउ इफ यू सी बार मैग्नेट को, इफ यू पुट इट, देयर आर आयरन फाइलिंग्स, यू नो, छोटे छोटे पिन्स वगैरह होंगे. तो अगर आप उसको यहां पर लगाएंगे, यहां से, तो दोनों तरफ इट विल गेट अट्रैक्टेड. Now this is the north pole जहां पे व्हाइट मार्क है. This is the south pole. कहीं इस पे N या S लिखा होता है. अगर N या S नहीं लिखा है तो N को it is denoted with a white dot. So it will get attracted like this. दोनों sides पे it will kind of get stuck. Now what happens is that we find the maximum iron filings stick near the ends of the bar magnet, that is the north and the south pole, while a very few iron filings stick at the remaining part of the magnet. Very little few will be stuck in the middle, but largely maximum 95% will be on the two ends of the magnet. Now these ends of the magnet are called the two poles of the magnet, which is, एक है नॉर्थ पोल, दूसरा है साउथ पोल. सिंपल, जैसे ग्लोब में होता है नॉर्थ पोल साउथ पोल, जैसे मैंने अभी दिखाया. ओके, तो मोस्ट ऑफ द आयरन फिलिंग्स स्टिक टू द पोल्स ऑफ अ मैग्नेट ऑफ एनी शेप. Now it is not possible to obtain a magnet with a single pole. ये बात को आप ध्यान में रखिए. ऐसा कोई भी मैग्नेट नहीं होगा जिसका कि सिर्फ एक ही पोल हो, सिर्फ नॉर्थ पोल हो या सिर्फ साउथ पोल हो. ऐसा बिल्कुल कभी भी नहीं होगा. अगर मैग्नेट को दो पीसेस में तोड़ा जाता है, अगर मैं इस मैग्नेट को यहां से, मैं सोचूं मेरे को साउथ पोल चाहिए ही नहीं, ओके, मैं इसको तोड़ दूंगा, तो मैं यहां से इसको आधा को तोड़ देता हूं. ओके, हालांकि इसको तोड़ना मुश्किल है. ओके, तोड़ दूं तो ऐसा नहीं होगा कि इसका साउथ पोल नहीं रहेगा. जो नीचे का पोर्शन है दैट विल बिकम द साउथ पोल. ओके, सो इट नेवर हैपेंस दैट अ मैग्नेट कम्स विद अ सिंगल पोल. ऐसा कभी भी नहीं होगा. ओके, सो नॉर्थ एंड साउथ पोल ऑलवेज एग्जिस्ट इन पेयर्स. इवन इन द स्मॉलेस्ट पीस ऑफ द मैग्नेट ए सिंगल नॉर्थ पोल और अ साउथ पोल कैन नॉट एग्जिस्ट. ओके, सो अगर आपसे ये प्रश्न पूछा जाए तो आपको ये पूरा लिखना है. मैं आपको और डिटेल में बता देता हूं. हाँ, सी बेसिकली होता क्या है, ए मैग्नेट के अंदर छोटे छोटे क्षेत्र होते हैं, जैसे हिंदी में बोलते हैं ना क्षेत्र, रीजन. देयर आर स्मॉल रीजन्स व्हिच आर कॉल्ड मैग्नेटिक डोमेन. थोड़ा एक्स्ट्रा इंफॉर्मेशन है, बट समझ लो, बिकॉज if you understand it, it becomes easy for you to write the answer. Now each domain is like a tiny magnet with its own north and south pole. जैसे अभी आप समझ लीजिए, इंडिया एक पूरा मैग्नेट है. इंडिया में कितने हैं? 28 states हैं, right? So each state is like its own magnet, okay, with its own north and south pole. Okay, I'm just giving you for comparison sake. In a magnetized material, these domains are aligned in the same direction, creating a larger overall magnet. So India is a bigger magnet, but within the magnet, there is an Andhra Pradesh magnet, there is a Maharashtra magnet, there is an Uttar Pradesh magnet with its own north and south pole. So overall magnetic field, it creates an overall magnetic field with the north and south pole. Kashmir north pole and Kanyakumari south pole. Okay, and just for comparison, ताकि आपको समझने में आसानी हो, इसलिए बोल रहा हूँ, India is not a magnet. Okay, though we are all attracted to it, right? Now, breaking a magnet, even when you break the magnet, the new ends that are created automatically become the new north and south poles. Okay, तो ये पूरा हो गया. Okay, now आगे चलते हैं. ये सब मैं उसको comments में मैं डाल दूंगा, तो कि it will become. Now we will do a few experiments. Now you suspend a bar magnet. Okay, you suspend a bar magnet with a thread like it is shown out here. Okay, I hope it is clear on the screen. Okay, you suspend the bar magnet like this. ये जो बार मैग्नेट है जो मैंने यहां दिखाया है, उसी को आप यहां पे सस्पेंड ऐसे करके लगाते हैं थ्रेड के साथ, और उसके ऊपर 2-3 किताबें रख देंगे ताकि वो वेट बना रहे. एंड देन यू रोटेट इट. यू रोटेट द मैग्नेट जेंटली इन द हॉरिजॉन्टल डायरेक्शन. ऐसे ऐसे नहीं, ऐसे ऐसे. ओके, हॉरिजॉन्टल डायरेक्शन. एंड थोड़ी देर बाद वेट फॉर इट टू कम टू अ कंप्लीट रेस्ट. बिल्कुल स्टेशनरी एक जगह पे. फैन को ऑफ कर दो ताकि कोई हवा ना आए. यू जस्ट कीप इट स्टेशनरी. नाउ मार्क द पोजीशन करस्पॉन्डिंग टू द एंड्स ऑफ द मैग्नेट. की इस डायरेक्शन में क्या वो ऐसे सीधा है, या थोड़ा सा ऐसे है, या थोड़ा सा ऐसे है, कौन सी डायरेक्शन में है उसको आप मार्क कर दीजिए. ओके, जॉइन दीज 2 पॉइंट्स ऑन द ग्राउंड विद अ लाइन. नीचे जो पेपर है ना, उसके हेल्प से यू मार्क इट. Now again rotate the magnet by giving a gentle push at one end and wait. Again repeat the experiment and see whether it is coming and stopping at the same line. What will happen is that it will generally stop in the north and south direction. So if you have noticed the direction where the sun rises or sets, we have an approximate idea of where the east or west is. Hence we can locate the direction along with which the magnet rests. Now for instance, I know this is the eastern direction in my house. This is the eastern direction, this is the west. So I know that this will be north and this will be south, right? So I know exactly which is the north and south direction. So a freely suspended magnet comes to rest along the north-south direction, what I just now explained to you. Okay, so the end of the magnet that points towards the north direction is called the north pole, the north seeking pole. The other end will be called the south pole of the magnet. A freely suspended magnet rests along the north-south direction because the earth itself behaves like a giant magnet. So the earth itself is a magnet, the magnetic field that I talked about, and any magnet will always rest in the north-south direction in alignment with the magnetic field of the earth. ओके, और उस हिसाब से आप ईस्ट और वेस्ट, साउथ ईस्ट, नॉर्थ वेस्ट डायरेक्शन का पता लगा सकते हैं. नाउ रिपीट दिस एक्टिविटी विद अ स्मॉल आयरन बार इन प्लेस ऑफ द बार मैग्नेट. नाउ ऐसा करो कि आप मैग्नेट को छोड़ो, मैग्नेट को साइड में रखो. आपके पास एक लोहे का एक पीस हो, कोई भी, आई मीन इट कुड बी इन द सेम शेप लाइक दैट. आपके पास एक लोहे का पीस होगा, घर पे कहीं ना कहीं तो होगा, लोहे का पीस होगा. तो उसको आप उसी तरह से टांग के सेम एक्सपेरिमेंट को आप अपने आप कीजिए. डू द सेम एक्सपेरिमेंट विद द आयरन पीस. ओके, सो एंड सी वेदर इट इज आल्सो रेस्टिंग इन द नॉर्थ साउथ डायरेक्शन. यू विल फाइंड दैट इट डज नॉट. An iron is a magnetic material, but it is not a magnet. Please remember this distinction. So this activity provides us with a way to test whether the piece of metal is a magnet or not. Okay, so it implies that only magnets rest along the north-south direction. only magnets rest along the north south direction. So this line is important. Okay, ऐसा नहीं है कि मैग्नेटिक मटेरियल भी वो उसी तरह का बिहेवियर करेगा जैसे मैग्नेट करता है, ऐसा नहीं है. सो ए iron piece will behave differently from a bar magnet. So the property of a freely suspended magnet to always rest along the northeast direction is used to find the directions. Based on this, a small device called a magnetic compass. Now if you see here, this is north south. Okay, 0 180 degrees. So depend, agar aapko north, suppose let's say we have to go in a northwest direction, so we will start moving in that direction. नाव को उस डायरेक्शन में ले जाना शुरू कर देंगे. So has a magnet in the shape of a needle which can rotate freely. So there is a magnet here, so which can rotate freely. The needle of a magnetic compass indicates the north-south direction. So in the olden days, for finding directions, it has a magnet. ये line को याद रखो, in the shape of a needle which can rotate freely. This figure, okay. The compass is kept at a place where we wish to know the directions. After some time, the needle comes to rest in the north-south direction. Always, it will always come to rest. I'm going on repeating this ताकि आपको एक तरह से revision हो जाए that it will always be in the north-south direction. And this the compass box is then gently rotated until the north and south marked on the dial are aligned with the needle. Now all directions to at that place are as indicated on the dial. Okay. Now, how can we make our own magnetic compass is what this student is wondering. Now, a magnetic compass is usually a small circular box with a transparent cover on it, as shown in figure 4.6, जो अभी यहाँ पे ऊपर देखा. The magnet in the shape of a needle is mounted on a pin standing at the bottom of the box. एक pin के ऊपर that magnetic compass, the needle is there, जिसमें magnet है. Okay, and that's why it always points in the north and south direction. This needle is balanced on the pin in such a manner that it can move around this pin easily, that it can rotate freely. The end of the needle which rests in the north direction is usually painted red. Below the needle there is a dial with directions marked on it. So that's what the compass looks like. मैंने आपको compass का photograph भी यहाँ पर, so that you know it's a very nice photograph. Yeah. So you know this is how a magnetic compass looks. You know, so you have a map. Okay, you have the ropes, etc. Because that's what is used by sailors on a ship. So this is what a magnetic compass essentially looks like. Okay, आगे चलते हैं. Now थोड़ा और, this is another experiment that we are going to do now. Now what you do is that एक iron sewing needle, जो अगर आपके घर पे एक लंबी सुई हो, okay, मेरे पास छोटी सुई मिली थी, वो यहाँ पे कैमरा पे दिखेगी नहीं. So लंबी सुई अगर आपके पास हो, मम्मी से पूछो, you take it and you get a bar magnet. This bar magnet, you get 2 for 130 rupees on Amazon. That's what I found out. I was going to order it, but then it said it will be delivered only after a week. Then I asked my father and he said, हाँ एक पड़ा है. This is from my school time. दूसरा पता नहीं कहाँ पे है. So you get 2 of this for 130 rupees. So you can use that for your experiments. So you get that. Okay, you buy that and this kind of an iron needle. So place the iron sewing needle. Okay. The sewing needle on a wooden table. Then keep any one pole of the magnet, north pole ho ya south pole ho. Okay, and then what you do is that move the magnet over the needle along its length as shown in figure 4.7. तो इस needle के पूरे length पर आप इसको रगड़ते रहिए. Okay, you keep pressing it and do it some 20 to 30 to 40 times. Okay, do it multiple times. Okay, just keep doing it. You repeat the previous step, repeat this process at least 30 to 40 times. Now what you do after you have done it, उसके बाद bring some iron filings. It could be this kind of safety pins also, or yeah, any kind of pins that you may have at home. उसको लेकर आइए इस needle के पास, इस सुई के पास. You bring the iron filings or a safety pin or whatever. Okay. Now what you do is that then it means that the needle has become a magnet, because these ones will get attracted to the needle, because what has happened is that it has become a temporary magnet, because the bar magnet has kind of given part of its magnetic power to the needle. So that's what has happened. So this ये experiment आपको करना है. ये इसके बाद then pass this needle through the cork. एक cork होता है ना, wooden cork जो होता है, okay, उसके थ्रू घुसाइए यहां पर जैसे इस तरह से है, और एक पानी के बोल में we are trying to simulate a ship kind of a thing. So this cork is like the ship and it is floating on water. So you fill a glass bowl filled with water and that the needle always remains above the level of water here. When the needle comes to rest, your magnetic compass, because it is already magnetized, the magnetic compass is ready for use. Note the direction in which either side of the needle points. Rotate the cork gently and wait till it stops rotating. Repeat this a few more times. Do the ends of the needle always point in the same direction? If it is retaining its magnetic quality, it will always point in the same direction. Tell me what direction it will be. Okay, ये अभी आपको मालूम होना चाहिए. Okay. इनफैक्ट ये एक हिस्टोरिकल ये है कि मैग्नेटिक कंपास की डिस्कवरी से पहले उसी तरह का एक डिवाइस का इस्तेमाल किया जाता था बाय इंडियंस फॉर नेविगेशन एट सी. इट कंसिस्टेड ऑफ ए मैग्नेटाइज्ड फिश शेप्ड आयरन पीस केप्ट इन अ वेसल ऑफ ऑयल. इट वाज कॉल्ड मत्स्य यंत्र और मच्छ यंत्र. मत्स्य यानी कि मछली. ओके, सो इस तरह का एक डिवाइस, एक यंत्र का इस्तेमाल इंडियंस करते थे बिफोर द डिस्कवरी ऑफ द मैग्नेटिक कंपास. इट वाज यूज्ड बाय सेलर्स. नाउ take a pair of bar magnets in which the north and south poles have been marked. Mark the two magnets as A and B. Okay, now what you do out here, now this is interesting. दो magnets को लेना है. ये A magnet है. Okay, magnet A है. Okay, north pole and south pole clearly divided. As I said, कि कई magnets में आपको north और south लिखा हुआ आएगा. अगर नहीं लिखा हुआ आया तो north को white mark के साथ denote किया जाता है. Okay. And then what you do is that you keep another magnet B. Okay, so magnet B में करेंगे. अगर यहां पर ऊपर नॉर्थ पोल है, नीचे साउथ पोल है, और मैग्नेट B का भी ऊपर नॉर्थ पोल है और नीचे साउथ पोल है, तो द साउथ पोल एंड द नॉर्थ पोल विल अट्रैक्ट. बट यहां पर अगर आप साउथ और साउथ को रखेंगे so it will kind of move away from each other. Okay, so that's what will happen. So you will see that unlike poles of two magnets, the north pole of one magnet and the south pole of another magnet attract each other. They will come closer to each other. The north, वो बोलते हैं ना, opposite poles attract. यानी कि if one person is very temperamental, गुस्से वाला है, the other person is very शांत, in most cases they kind of attract each other, they like each other. But if both are of a similar kind, they probably repel each other. So the like poles, that is either the north poles or the south poles of both magnets, repel each other. तो अगर आप दो magnets को लेके आएंगे, let's assume, assumption के लिए कि ये हो गया इसका नॉर्थ पोल, ये व्हाइट डॉट दिख रहा है, ये हो गया इसका साउथ पोल, ये ब्लैक वाला नॉर्थ पोल है, ये साउथ पोल है. तो अगर मैं इसका नॉर्थ पोल इसके साउथ पोल के पास लेके आऊंगा तो इट विल अट्रैक्ट ईच अदर, इट विल मूव क्लोजर टू ईच अदर. हाउएवर अगर मैं इसका नॉर्थ पोल और इसका नॉर्थ पोल रखूं तो इट विल मूव अवे फ्रॉम ईच अदर, या ये दोनों करूं साउथ पोल और साउथ पोल, इट विल मूव अवे फ्रॉम ईच अदर. सो दैट्स हाउ इट विल हैपन. दैट्स अनदर थिंग दैट यू नीड टू नो अबाउट द इंटरेक्शन बिटवीन टू बार मैग्नेट्स. ओके, नाउ एक और एक्सपेरिमेंट है, इसमें पूरे एक्सपेरिमेंट ही है. साइंस फिजिक्स में ज्यादातर एक्सपेरिमेंट्स ही हैं. Now take a magnetic compass and a bar magnet. अब magnetic compass अगर आपके लेबोरेटरी में है तो देखना पड़ेगा. Ask your teacher. Okay, so place the magnetic compass over a horizontal surface and wait for the needle to come to rest. Now slowly bring the north pole of the bar magnet closer to the north pole of the magnetic compass. समझे? अगर वो needle है, suppose ये north है, ये north है, तो आप बार मैग्नेट के नॉर्थ पोल को इसके पास लेके आते हैं. ओके, सो व्हाट विल हैपन? सो यू स्लोली ब्रिंग द नॉर्थ पोल ऑफ द बार मैग्नेट क्लोज टू द नॉर्थ पोल ऑफ द कंपास नीडल एज शोन इन फिगर 4.9a जो पहले था. ऑब्जर्व द कंपास नीडल केयरफुली. व्हाट डू यू ऑब्जर्व? डज द नीडल डिफ्लेक्ट? इफ यस, इन विच डायरेक्शन? दैट्स एन एक्सपेरिमेंट दैट यू नीड टू डू. तो इस तरह से लाइक नॉर्थ पोल है, यहां पर मैग्नेटिक कंपास है, तो अगर नॉर्थ पोल यहां पर आएगा नॉर्थ के पास, तो होगा ये कि जो उसका जो कंपास का वो नीडल है वो दूसरी तरफ चला जाएगा. व्हाई? बिकॉज नॉर्थ एंड नॉर्थ डोंट कम टुगेदर. वेयरएज अगर आप साउथ पोल को पास लेके आते हैं तो यू विल सी दैट द नीडल कम्स दिस साइड. द नीडल कम्स, बिकॉज ये नॉर्थ वाला है ना, समझ में आ गया ना, ये नॉर्थ वाला है, तो नॉर्थ वाला इट विल स्टार्ट मूविंग टुवर्ड्स द बार मैग्नेट का साउथ पोल. लेकिन अगर नॉर्थ पोल होता तो इट विल मूव टुवर्ड्स द अदर साइड, इट इज रिपेलिंग. ओके. Now, when the north pole of a magnet is brought closer to the north pole of the compass needle, it moves away as shown in figure 4.9a. When the south pole is brought this thing, it moves closer. समझ में आ गया यहां तक? Okay. Now, what happens is that अगर हम बीच में कोई इस चीज के पीछे, इसके बीच में सेम चीज को एक्सपेरिमेंट करते हैं, बीच में एक लकड़ी का पीस लगा देते हैं, या कोई कागज लगा देते हैं, या कोई ग्लास का पीस लगा देते हैं. ओके, लकड़ी का पीस या नहीं है. ओके, तो अगर हम बीच में फॉर इंस्टेंस अगर यहां पे है, तो एक लकड़ी का पीस, बार मैग्नेट यहां पे है, बार मैग्नेट यहां पे है, और इस तरफ मैग्नेटिक कंपास है, तो हम लकड़ी के पीस को हम बीच में लगा देते हैं. तो क्या उससे ऐसा होगा कि देन द सेम रिएक्शन विल नॉट हैपन, इट विल नॉट मूव अवे और मूव क्लोजर, ऐसा नहीं होगा या नहीं, इसका एक्सपेरिमेंट भी आपको करना पड़ेगा. तो ये लकड़ी का पीस है, ये बार मैग्नेट है, and in the normal circumstances it is moving this side. So what happens is that, so the conclusion is that there is no appreciable change in the deflection of the needle. तो लकड़ी हो, ग्लास हो, पेपर हो, बीच में लगाने पर भी okay, we can conclude that the magnetic effect can act through non-magnetic material. तो हालांकि ये जो लकड़ी का जो मटेरियल है, दिस इज नॉन मैग्नेटिक इन नेचर, उसके बावजूद द मैग्नेटिक इफेक्ट बिटवीन द बार मैग्नेट एंड द मैग्नेटिक कंपास रहेगा. इट विल नॉट मेक एनी डिफरेंस. यानी कि वी कैन कंक्लूड दैट द मैग्नेटिक इफेक्ट कैन एक्ट थ्रू नॉन मैग्नेटिक मटेरियल्स. इस सेंटेंस को याद रखिए. आई होप आपको समझ में आ गया. ओके, आई होप यू हैव अंडरस्टूड दिस एंड यू नीड टू रिमेंबर दिस सेंटेंस क्लियरली. नाउ लेट्स हैव सम फन विद मैग्नेट्स. ओके, ये मैंने आपको राइट एट द बिगिनिंग ही बता दिया है. सो वी हैव ऑलरेडी, इन फैक्ट वी स्टार्टेड विद हैविंग सम फन. ओके, व्हाट आई शोड यू विद द सेफ्टी पिन्स एटसेट्रा, दैट you Reshma was very excited and decided to run some fun activities using magnets at a school fair. You may try making this. So when you pick this up, ये जो पिन होते हैं ना, जो जिसको कि आप बोर्ड पे लगाने के लिए करते हैं, तो बोर्ड के साथ उसको चिपका जस्ट लाइक व्हाट आई डिड विद द सेफ्टी पिन, यू कैन मेक इट एंड मेक इट ऑलमोस्ट लाइक अ गार्लैंड, माला की तरह. ओके, यू कैन, सो इट इज, यू कैन कॉल इट द मैग्नेटिक गार्लैंड. ओके, सो दैट इज वन थिंग. देन this is another one. Like, can you do this of, you know, glass के अंदर pin है, can you be able to do that? Based on what I have told you, you should be able to answer this question. Similarly, this kind of with two cars, this thing. Now, if you see, match box के साथ, buttons के साथ, और उसके ऊपर एक bar magnet लगाया है. Okay, दो गाड़ियां लगाई हैं. Okay, now you tell me, will these two cars move closer to each other or move away from each other? जल्दी बताओ, जल्दी बताओ. टाइम कोड लिख के मेरे को इसका आंसर मांगता. ओके, सो प्लीज टेल मी, दिस इज द नॉर्थ पोल, दिस इज द नॉर्थ पोल. आई टोल्ड यू द व्हाइट डॉट जो मेरे बार मैग्नेट में है. सो मेरे को ये बताओ, मुझे ये बताओ कि वेदर इट विल मूव क्लोजर, द टू मैच बॉक्स कार्स विल मूव क्लोजर और विल दे मूव अहेड. ओके, दिस इज योर क्वेश्चन, यू नीड टू टेल मी. ओके, यू शुड बी एबल टू. या ये तो मैंने आपको बता दिया दैट इट्स हाईलाइटेड बाय अ व्हाइट डॉट. नाउ magnets को what I told you that this particular pen that I have in order to write on the board, इसके अंदर भी एक मैग्नेट है. ओके, तो इसको मैं सीधा, मेरा ये जो टेबल है that is a लोहे का टेबल. So if I put it straight, by mistake कभी कभी हुआ है, टप करके चिपक जाता है, which is not good for the pen. So I have to always keep it inside a cardboard box so that it does not get attracted to the magnetic surface, to the magnet. So what you do to store it is always you either keep it with a wooden surface, ideal, or a cardboard box, something which is non-magnetic in nature. That's how you do it. You don't heat up a magnet, you don't keep it in very hot kind of temperatures, you don't kind of try to break it with a hammer. Definitely don't keep it near mobile phones. It can harm. In fact, when my father was giving it to me and he put it, I said, no, don't keep it near the mobile phone. It can harm the mobile phone. Or TV remote या AC remote उसके पास नहीं रखने. So please remember all these keywords: attraction, bar magnet, magnetic compass, conclude, construct, magnetic middle, non-magnetic, north pole, south pole, repulsion, ring magnet, predict, investigate, ये तो हो गया. South pole, U-shaped magnet, ये सब आपको मालूम होना चाहिए. So this is the summary which if you revise once, I am 100% sure, 110% sure आपको पूरी तरह से समझ में आ गया. I enjoyed preparing for this chapter. I enjoyed doing this chapter, explaining this chapter, and I do hope आपको भी मजा आया, सब कुछ समझ में आ गया. Even the extra information that I've given you, it helps you get more clarity about this thing, especially the difference between gravity and magnetism. So the question and answers we will do in a separate video, so that पहले I want you to focus on understanding. उसके बाद we will do the question and answer, so that there is more clarity. And I'll also suggest to you what would be the best book for you to refer to if you wish to, so that it can help you further fine tune yourself, test yourself before you go for your exams in school. वो मैं आपको सितंबर में बताऊंगा. Okay, so that's the thing. So ये सब enhance our learning वगैरह बाद में करेंगे. Please make sure that you go through the summary so that it is absolutely clear. So with that, I come to the end of this particular chapter, chapter 4 of Curiosity textbook for CBSE Class 6 Science. Thank you very much for watching. The next chapter will be, I think, on measurements, which is again quite fascinating. तो काफी मजा आएगा. जल्दी ही मिलते हैं. टाटा, बाय बाय, नमस्कार.